Hi everyone, welcome to all of you on my YouTube channel. So here I am going to talk about the third PYQ series of distillation, that is distillation mass transfer. So already I have discussed lots of questions before this from distillation mass transfer. So till now I have discussed questions till 2005. Now I will be starting with this particular problem. So here you can see this question is based on the design problem and designing of distillation column. So the question says that a saturated vapor is fed to the distillation column. Whenever there is a saturated vapor, the value of Q will be equals to 1. Sorry, the value of Q will be equals to 0, right? And when we talk about Q, so Q is equals to L bar minus L divided by F, that is equals to Q, and you can divide that V minus V bar divided by F, that is equals to 1 minus Q. Is that clear? So this one is the case. So here you can see that the 60% of their respective flooding velocity. So again in both stripping and rectifying section, so U operating and rectifying section can be written as 0.6 multiplied with U flooding in rectifying section, and U operating in stripping sections can be written as 0.6 multiplied with U flooding in stripping section. And the flooding velocity of rectifying section, U flooding velocity in rectifying section, that is equals to 2 multiplied with U flooding velocity in stripping section. So these are the data that have been given to you, and the question says that the assumption of constant molar flow rate and constant molar vapor density throughout the column are valid if the boil-off ratio, so boil-off ratio is given to you, let's say BR, that is equals to 60 kilomole per hour. Then the relationship between diameter of the rectifying section, so you are supposed to calculate what is dr divided by ds, something like that. So okay, so when we talk about the value of q is equals to 1, so I can write v minus v bar divided by f, that is equals to 1 minus q, that is equals to 0. So from here we can get v equals to v bar, means vapor flow rate in stripping section is equals to vapor flow rate in the rectifying section. So if I am talking about vapor flow rate in stripping section, can be written as rho into density of column of rectifying section multiplied with and U operating of rectifying section. And again if I can write V bar, that is equals to density of vapor multiplied with density of cross sectional area in stripping section multiplied with operating velocity in stripping section. So let's say if this one is equation first and this one is equation second, so if I divide equation first and second, I can get V divided by V bar, that is equals to rho into cross sectional area in rectifying section, that is equals to pi by 4 multiplied with d rectifying whole square, and U operating velocity in rectifying section. So I can write 0.6 multiplied with U flooding velocity in rectifying section and divided by rho multiplied with obviously pi by 4 into diameter of a stripping section whole square multiplied 0.6 into U flooding velocity in a stripping section. So if you do these calculations, it will get cancelled out, density will get cancelled out, pi by 4 will get cancelled out, 0.6 and 0.6 get cancelled out. And also there is a relationship that U are in a rectifying section, flooding velocity in rectifying section is equals to 2 into flooding velocity in stripping section. So U flooding velocity in a stripping section multiplied with diameter of a stripping section required, that is equals to diameter of rectifying section required square multiplied with flooding velocity in rectifying section. So U flooding velocity in a stripping section into diameter of a stripping section required, that is equals to dr square multiplied with 2 multiplied with U flooding velocity in a stripping section. Now you can cancel out this and this, and you can say that diameter of rectifying section divided by diameter of a stripping section, that is equals to 1 by 2. Sorry, this is given in opposite way. So here I can say 2 multiplied with d rectifying d stripping section whole square, that is equals to d and d stripping section into r. So now if you want to cancel it out, you can cancel it out. Sorry, this is U flooding. So again I'll write, it has been given that the flooding velocity of rectifying section is twice that of the stripping section. Okay, so okay, so flooding velocity of a stripping section is rectifying section is twice. So here you can see that this will get cancelled out. So ds square multiplied ufs, that is equals to 2 multiplied with, sorry, dr square multiplied with flooding velocity in r. So it can be written as ds square multiplied with 2 multiplied with ufr, that is equals to dr square multiplied with ufr. Now you can cancel it out. Finally this will get cancelled out. So finally you will get diameter of rectifying section will be equals to root 2 multiplied with diameter of stripping section. This thing, is that clear? So from here you can see your option A will be your correct answer. Next question says that in a distillation operation, it is desired to have a very high purity bottom product. Initially, kettle type revolver is used at the bottom of the column. So when we talk about the distillation column here, so you can see in the bottom of the distillation column we have a kettle type revolver right now, kettle. And the following analytical method is being used to calculate the number of stages in the distillation column, where xm is the composition of the liquid leaving a mat tray and m is the least equilibrium tray obtained at McCabe graph. Now it has been it's saying that the kettle type revolver is replaced by a thermosiphon revolver, the analytical equations of that thing. So when we talk about the kettle type revolver, it used to work as a partial revolver, and a partial revolver work as a one ideal stages. Partial revolver work as ideal stages. So if I am replacing partial revolver, that is kettle type revolver, by thermosiphon revolver. Thermosiphon revolver. So in that case you can say that this does not work as a ideal state. This does not work as a ideal stage. So when we talk about the number of stages calculation, you have to subtract 1. So if I'll subtract these things by 1, so np minus 1 you will get, np minus m. So this one will be your correct option. Option C will be your correct. So the crux point of this question was that you have to understand the concept regarding the thermosiphon revolver and kettle type revolver. So kettle type revolver does not work as a partial revolver, that is also considered as a one ideal stage, but thermosiphon revolver does not work as an ideal stage. That's why in formula you have to subtract 1. Now moving towards the next problem. This problem is also very very important, and question from this particular concept is being repeated every 2 to 3 years from the batch distillation or release distillation. The question says that a batch distillation operation is carried out to separate a feed containing 100 moles of binary mixture of A and B, right? So feed is there which contains 100 moles of A and B. So A is there and B is there. The distillation progress until the mole fraction of A in the feed is, so if I am talking about mole fraction of A in the feed is 0.7. The distillation progress until the mole fraction of A in the residue decreases to 0.6. So XW is equals to 0.6. So let's say I am assuming A is the more volatile component. So mole fraction of A in the feed is 0.7. And the equilibrium curve is given. So equilibrium curve Y star is equals to 0.7353 x plus 0.3088. The number of moles of residue is, so you are supposed to calculate residue is what. Is that clear? So let's try to understand. If I'll directly write the formula, so formula I can directly write, but I am telling you how to derive this formula. So it may be possible sometimes you may forget the problem. So let's say if you have a distillation batch distillation unit and it is getting distillate. So initially let's say n number of moles was there and distillate is D. Is that clear? So when there is a differential decrease in number of moles, that will be equals to differential increase in number of distillate. So in the differential decrease in number of moles of feed will be equals to differential increase in number of moles of distillate. Now this is the overall balance. Now coming to component violence. So let's say if y star is our equilibrium composition. So if I am talking about y star dd, that should be equals to minus of d, or I can write that is equals to d of x into n, d of x into n. Is that clear? So I can also write y star dd, that is equals to x dn plus n dx, right? And what is dn? Dn can be written as minus d of d. Is that clear? So here there will be a minus sign here if I am doing the component balance, right? So now let's substitute these things here. Y star dd, that is equals to minus x, and dd equals to x dd minus n dx. Is that clear? So let's take dd one side. So I can write y star minus x dd, that is equals to minus n dx. So now I can write, and again dd can be written as minus dn. So I can write y star minus x and minus dn, that is equals to minus n dx. Minus and minus will get cancelled out here, and again you can say that dn divided by n, that is equals to dx divided by y star minus x. So if I do the integration from f to w, so it will go xf to xw. Is that clear? So this one is the integration. So I can write now ln w divided by f, that is equals to integral xf to xw, and again dx divided by y star minus x. So this one is our final formula for the released distillation. So you are supposed to calculate w here in this problem, and y star is given to you. So I can write ln w, and f is given to you, that is your 100, and y star is given. So ln w by 100, that is equals to again xf to xw, and y star is 0.7353x, dx divided by 0.7353x plus again 0.3088 minus x. So this is just a basic integration. Now you can calculate ln w divided by 100, that is equals to integral xf to xw, and once you subtract these things you will get dx divided by 0.3088 minus something, so 0.2657x. So once you integrate these things, you know the value of xf. Xf is given to you how much? 0.7 and 0.6. So this one is 0.7 and this one is 0.6. So once you do the integration, you will be able to calculate the value of w. So the most important thing that I just wanted to tell you how to derive this formula, because sometimes in the examination you will forget this formula in the pressure, due to the pressure of examinations. But again, the method that I have told you, that is the very simple method, and you can derive this formula directly there. And this equation is also called as released distillation or batch distillation, right? Okay. After that, I'll move towards the next problem of today's discussion, and here you can see that the feed of a binary distillation column has a 40 mole % of vapor and 60 mole % of liquid. So what is Q? Q is the percentage of liquid in the feed, so that is equals to 0.60, and they are telling you what is slope of Q line. So slope, that is equals to Q divided by Q minus 1. So that is equals to 0.60 divided by 0.60 minus 1, that is equals to 60 divided by 40, 3 by 2, that is equals to, sorry, that is minus, that is minus 1.5. Your option A will be your correct answer. So if you want to write equation of Q line, so Q line equations can be written as Q upon Q minus 1 into x minus ZF divided by Q minus 1. So this one is a Q line equation, and that is also called as the feed line equation sometimes. So when we talk about this equation, so you can see that this equation goes like that, and having a slope and negative intercept, something like that. So this equation looks like that way. So there is slope and there is negative intercept. Okay, so after that I'll be moving towards the next problem, and here you can see the question is from flash distillation. So in this particular problem, you can see a flash distillation drum is used to separate methanol water mixture. The mole fraction of methanol is in the feed is 0.5. So XF is given to you 0.5. And the feed flow rate F is also given here, that is 1000 kilomole per hour, and the feed is preheated in heater. QH is the subsequently heat is flashed in the drum. The flash drum can be assumed to be an equilibrium stage, and operating adiabatically, the equilibrium relation between y is given. Equilibrium relation is y equals to 4x is given to you, and you are supposed to calculate, and the ratio of distillate to feed. So distillate divided by feed is equals to 0.5. So feed is 1000, so D will be equals to 500. So if D is equals to here 500, so again W, if I am assuming distillate bottom is 500, right? And after that also the mole fraction of methanol in distillate. So you are supposed to calculate XD. So if I will write the balance here, F into XF, that is equals to D into XD plus W into XW. This is just a single component balance. So F into XF is your how much? 50%. So 500, that is equals to D 500 multiplied with XD plus W is 500 multiplied with XW. So the ratio and mole fraction of distillate and mole fraction of methanol in the feed is given to you. Okay. And let's say if XD is here y, XD is equals to y, so y is equals to 4x, that is given 4xw. So what is xw? Xw is y divided by 4. So I'll substitute these things here. So I can say that 500 will get cancelled out from both sides. So 1 equals to y plus xw. So 1 equals to y plus xw is y divided by 4. 1 equals to 5y divided by 4. So y will be equals to how much? 4 divided by 5, that is equals to 0.8. So here your mole fraction of methanol in distillate will be equals to 0.8 first. Second thing is that this is the second problem is based on the energy balance, and the question says that if the enthalpy of distillate with reference to the feed means enthalpy of distillate means HD minus HF is given as let's say 3000 kilojoule per kilomole, and the enthalpy of bottom HW minus HF with respect to feed is minus 1000 kilojoule per mole, then you are supposed to calculate what is Q dot H. So since the energy is being entered into this distillation column due to feed, this one is entering and this one is coming out, right? So can I say that F multiplied with HF plus Q dot H, that is equals to D into HD plus W into HW. So F can be written as D plus W into HF plus obviously Q dot H, that is equals to D multiplied with HD plus W multiplied with HW. So again I can write Q dot H can be written as D into obviously HD minus HF plus W multiplied with HW minus HF. So now you can see the value of HD minus HF and HW minus HF is given to you. So Q dot H can be written as 500 multiplied with HD minus HF is your 3000 plus W is also 500 multiplied with H, this one is minus 1000. So Q dot H, if I take 500 common, so 3000 minus 1000 is 2000 kilojoule. So that is equals to 10 into 10 to the power 5, that is equals to 1 into 10 to the power 6, and the unit is in kilojoule per hour. So from here you can see the option C is your correct option, right? So this question was really good based on the flash distillations, but again in flash distillation maximum these kind of things can be asked. Nothing much is there in the flash distillation, but yes, you should understand how to do energy balance, how to do overall balance, how to do the component balance, right? This question was asked in 2009. Now moving towards the next problem, this is also really good question from the Mercalli diagram, and the question says here that a binary feed mixture containing equimolar entities of component S and T. So there is S and there is T, two component is there in the binary solution. The distillate contains 96% of S. So let's say XD, mole fraction of XD is 0.96 in distillate. The Q line intersects the equilibrium line at X. So let's say if I am making a Mercalli diagram here, you can understand from here only. So this diagram looks like that way. Right, and if you see this value is given to you here, that is XD 0.96, and it has been said that the equimolar, the binding mixture equimolar feed is there. So the feed line will start from here, and here ZF is equals to 0.5. So the Q line intersects the equilibrium line at 0.46. So let's say if I am assuming this one is the Q line, So the coordinate x coordinate of q line here is 0.46 and the y coordinate of this q line is your 0.66. So when we talk about the rectifying section line, that will pass through this point only, then right, this one is the rectifying section line and this coordinate is your xd divided by r plus 1. Okay, so I can calculate the slope of rectifying section equation line. So this point will be your 0.96 and this coordinate will be 0.46 and 0.66. so if you know the slope of rectifying, and see, one more thing is that whenever the q line and rectifying section equation line cutting at these things, no, equilibrium curve, then that work as a minimum reflux ratio point, right? So when we talk about the slope of this line, or what is the intercept of this line, so intercept is not known to you. So if I'll calculate slope here, so slope will be called as rm divided by rm plus 1. And what is the slope of this line? That is equals to 0.96 minus 0.66 divided by 0.96 minus 0.46. So that value will give you rm divided by rm plus 1, that is equals to 0.30 divided by 0. Obviously 50. So that is 3 by 5. So 5 rm, that is equals to 3 rm plus 3, 2 rm, that is equals to 3. So minimum reflux ratio here you can get is 1.5. Is that clear? So this is very simple question. This is basically based on the graph, but again the graph has not given to you, but you can understand what sort of point is there. And this is very simple graph. You don't need to, you don't require any skill for making this kind of graph. So hypothetically you can assume any kind of skill and you can still plot this curve in the exam also. So based on this, your option B is correct. So the feed is at dew point. So now you can calculate the slope of this q line also. So q line slope will be 0.5 and 0.5 will be this point. So what is slope of q line? So slope of q line is q divided by q minus 1, that is equals to 0.66 minus 0.5 divided by 0.46 minus 0.5. Is that clear? So you can say q divided by q minus 1, that is equals to 0.16 and divided by 0 minus 0.04. So this will get cancelled out by minus 4. So q equals to minus 4q plus 4. So 5q equals to 4, q equals to 0.8. So q is lying 0 is less than, q is less than 1. So this will be work as a partial liquid and partial vapor. So you can see the q will be partially vapor, something else. Is that clear? Okay. Now I will be moving towards the next problem. In the Machiavelli diagram, if x coordinate of the point of intersection of q line and the vapor equilibrium curve is greater than the x coordinate of the feed point, means if they are saying you that if this q line would be looking like that, something, right? So what is the condition of feed? So here this you can say that slope is positive. So if q divided by q minus 1 should be greater than 0, if it is positive it has to be positive, or if it is negative it has to be negative. So in that condition, if you can say that feed is at below bubble point, right? So this condition with liquid below bubble point. So you can see option B is correct. Now coming to the next part of this particular problem, this question is a long question here. So you can say I am removing these things after that to solve this last question part of this particular problem. You can see an equimolar mixture of A and B is flash distilled continuously at a feed rate of, so here equimolar mixture of feed is there. So F is equals to, let's say 100 is given to you kilomole per hour, and XF is also given 0.5 because equimolar feed is there. The liquid product contains 40% of A. So here XW is equals to 0.40. The relative volatility alpha is 6. Then the vapor product in kilomole is F. L is given. So X, you are supposed to calculate F, V. So what is F? F is equals to V plus W. Is that clear? This is my equation first. So 100, that is equals to V, we don't know, and W also we don't know. This one is equation first, and F into XF is equals to V into Y plus W into X. So F is 100 into 0.5, that is equals to V into Y we don't know, plus W into X also we don't know, but relative volatility is known to you. So when we talk about the equilibrium distillation here, so Y can be written as Y equals to alpha X upon 1 plus alpha minus 1 into X. This is a relation between Y and X at equilibrium. If equilibrium, this relative volatility is given, so that is 6X divided by 1 plus 5X. Is that clear? So we can write this in this way, and after that we can calculate that 50, that is equals to V multiplied with Y is 6X divided by 1 plus 5X plus W into X. Is that clear? And X is given to you 0.4. So what is Y? Y is equals to 6 multiplied with 0.4 divided by 1 plus 5 multiplied with 0.4. So 2.4 divided by 1 plus 2. So that is 2.4 divided by 3, that is equals to 0.8. So Y is 0.8. Is that clear? So directly now I can write here that is 0.8, and X is also given to you, that is 0.4. Is that clear? So now we have two equations and two unknowns, so we can solve this equation. So let's say, so I can write 25, that is equals to, if I'll take 0.4 common, so that is equals to, or sorry, 50, that is equals to, if I'll take 0.4 common, so I can write 4V plus W, and it will go 500 divided by 4, that is equals to 4V plus W. So 125, that is equals to 4V plus W, and 100, that is equals to V plus W. So if I'll solve this equation, I'll make it, so it will get cancelled out. So 3V, that is equals to 25, so V will be equals to 25 by 3, right? And what is, so you are supposed to calculate, oh sorry, it will be 2. So that will be V is equals to 25 only. Okay, so the value of vapor flow rate will be here 25. That is the correct answer. Okay, that ends this question. Now after that I'll be moving towards the next problem, and the question says that binary feed containing 25 mole percent of liquid and 70 mole percent of vapor separated in a stage distillation unit. So what is Q here? Q will be equals to 0.25, because 25% of feed is in the liquid form. That's why this is value of Q. The mole fraction of more volatile component distillate XT is given to you, that is equals to 0.95. The molar flow rate of distillate is 50% of the feed flow rate. So let's say if I am assuming feed is 100, so what is distillate? Distillate is your 50. Mechanically can be used to analyze the column. The Q line intersect the operating line of the enriching section at 0.35 and 0.5 on the XY diagram. The slope of a stripping section line is equals to, so directly I can say that slope of a stripping section L bar divided by V bar, that is equals to R plus Q multiplied with F divided by D plus R plus 1 plus Q minus 1 into F divided by D. This is the slope of a stripping section equation line, right? So again you have to calculate the value of R first. So if you see the distillation column, that looks like that. So distillation column, sorry, McCabe-Thiele diagram. So it looks like in this way. There is this equilibrium curve, and after that you will be having a Y equals to X line, and you can say there is this line is there, that is called as the rectifying section equation line. And at this point you can see this coordinate is given 0.95 and 0.95. Is that clear? And after that also you can see that the molar and the Q line intersects the operating line of the enriching section at 0.35. So here okay, so you can see that there is a Q line something that will be going here, And what is slope of q line? Q divided by q minus 1. So 0.25 divided by minus 0.75, that is equals to minus 1 by 3. So it will be going like that something. And this rectifying section stripping line, rectifying section line, cutting q line, something like that at this particular point. Is that clear? So let's say coordinate of this point is 0.35 and 0.5. So can I calculate the slope of this line, rectifying section line? So r divided by r plus 1 can be written as 0.95 minus 0.5 divided by 0.95 minus 0.35. So that can be written as 0.45 divided by 0.60. So that is equals to 3 by 4. So I can write now 4r, that is equals to 3r plus 3. So r will be equals to 3. So from here we got the value of r, and we know the f, we know the f by d. So what is f by d? F by d is the value 2. So I can write slope of a stripping section line, that is L by V, that is equals to 3 plus q is 1 by 4 multiplied with 2 upon 5 by 4 plus, so minus 3 by 4 multiplied with 2. So that is equals to 3 plus 0.5 divided by minus 5 minus 6. So minus 1 divided by 4. So that is equals to minus 4 multiplied with 3.5. So that is equals to minus 14. So slope is minus 14, something like that. Okay, so but you have to calculate these things. So again you can calculate, and you can think like that. Okay, so with that I would like to end the lecture here only. In the next lecture I will be starting with question 4.43, right, from 2060 onwards, and the next lecture I will be able to complete the whole distillation question. Okay, thank you.